Alright, so today we're looking at some molarity practice problems, and we're going to go ahead and get started with exercise 1. Now before we get started, we need to go ahead and have a general understanding of the molarity equation. We need to understand that molarity is going to be equal to your moles of solute over liters of solution. And so we're going to use that to solve our problems, keeping in mind that when we talk about moles of solute, we can get that value using the molar mass if we have something in question. So let's go ahead and look at the first exercise problem, shall we? Here it says, calculate the molarity of a solution prepared by dissolving 11.5 grams of solid sodium hydroxide in enough water to make 1.50 liters of solution. So I like to diagnose what I'm given and kind of extrapolate what I'm solving for. It's obviously in this question asking for molarity. So molarity is the question. I do know my volume. My volume is going to be equal to 1.50 liters. And what I do not know is my moles of solute. So I don't know that, but I do know how to obtain that value. All I have to do is go from 11.5 grams to moles. And in order to do that, we're going to need to know our molar mass of sodium hydroxide. Now, if I'm converting my mass to moles, I start off by converting 11.5 grams. And because I want to find the number of moles, I'm going to divide that 11.5 grams of sodium hydroxide by its molar mass. Now the molar mass of sodium hydroxide is roughly 40 grams per 1 mole. And so using basic calculator, if I divide 11.5 by 40, I get an answer of 0.288. Let me just go ahead and round that to 3 sig figs. And that's moles of NaOH. But I need to find my molarity. So all I'm going to do is take that extracted value and divide that by my known volume. So 0.288 moles divided by 1.5 liters should give me my answer. And when I calculate that out, I get the answer of 0.192, and conveniently that checks out with this down here. Now I'll go ahead and put my units and such. So that's how you solve that question. Remember, you have to convert the given mass to moles because it's giving you mass to begin with. That's the mass of your solute because that's the sodium hydroxide. And then it's 1.50 liters of solution. Alright, so let's look at question number 2, shall we? Now with question number 2, you are being tasked with calculating the molarity. And you're going to be given mass again, and you're going to be given volume of a solution. Now, I will go ahead and write down that my molarity is my question mark. My volume, in this case, is going to be 26.8 milliliters. I will need to convert that to liters. It needs to be converted to liters. Again, I'm given mass like I was given before, and I'm going to use my mass to convert that to my moles. So 1.56 grams of HCl, and it's going to be converted to moles. Alright, so first things first, I'm going to convert to moles. To do that, I take my 1.56 grams HCl, divide that by the molar mass of HCl, That roughly ends up being like 36.45. I just know that because I've worked with this material for a while. Grams HCl. If you need the breakdown of it, the way it works is hydrogen's roughly 1.01, and I believe chlorine is 35.45. So 36, oh, I was off, 36.46. And that's my molar mass of HCl. So HCl here, I'm going to divide that 1.56 by 36.46. And that's going to give me roughly 0.428. I'm rounding. And that's moles of HCl. I'm going to need to divide that by my volume, but remember my volume must be converted to liters. Now to convert 26.8 milliliters to liters, I simply just divide 26 by 1,000, which ends up being 0.0268 liters. And you have to kind of know that conversion to be able to effectively solve it. Rewriting it, 0.0428 moles of HCl, which is my solute, is going to be divided into the total solution, which is the 26.8 milliliters converted to liters, 0.0268 liters. So then, take that answer, divide 0.0428, and divide that by 0.0268, and I yield 1.597, which can be rounded to 1.6. So 1.6 molar HCl. So in the first question, you're given your volume in liters, and you're given a mass in grams, which you're then tasked with converting to moles by dividing by the molar mass. In the second question, you're given your mass, and your volume of solution is given in milliliters, so you have to convert both of those to effectively solve it, converting this one by dividing this by the molar mass, and then converting the milliliters to liters to get your answer. Now when that's said and done, you can divide your moles by your liters, and that's the equation for molarity. So remember, this is what we use to get the answer, and it checks out. Now, in this last example, it's a little bit different. You're tasked with dealing with molarity, but you're dealing with ions. And one of the keynote points of view that you need to recall or make sure that you're in knowledge of is that you want to multiply the ions by their subscript if that's how many are present in blah 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 molar solution of the whole compound. So let's go ahead and take a look at an example where we have these various concentrations of solutions. So if we're looking at a molar concentration of 0.50 cobalt nitrate, well, cobalt 2 nitrate, excuse me, they are tasking us with determining what will be the relative ion concentration of each of these two ions. Now, prior knowledge kicks in here. I know that cobalt is an ion that combines with this nitrate polyatomic ion. I also see that there are two of these guys for the nitrate. So there's one CO, and then there's going to be two of these NO3s. And so because there are two NO3s, the molar concentration is going to double for the nitrate. This means that 1 times 0.50 for this one is going to be 0.50 for the cobalt ion. And for the nitrate ion, because there are two polyatomic ions emanating from this coefficient, this 2 means there's two of these groups. That means that 2 gets multiplied by the 0.50 molarity, and that yields a molar concentration of 1.0 molar for NO3 1 minus. Now, in order to do this, you have to have a familiarity with your ions. Otherwise, it's kind of all for naught. And effectively, this is the reverse of crisscross method when they come together. And just like I say, when you know your ions and you're familiar with the charge balance method, you can deduce how these each are given a certain concentration or contribute to the total concentration of that solution. So let's look at letter choice B. In letter choice B, it's broken down into 2 ions. There's iron 3 plus, or iron 3, if you will. And then you have this guy. Let me make some room here, sorry. Let's see, plus CO4. And remember, you got 3 of these guys here. You got 1 here. So in terms of multiplying the concentration, this is 1 times 0.50. That equals 0.50. And then because this one has 3, it's 3 times 0.50. That ends up being oh, sorry, I have the wrong concentrations written down. I'm sitting here trying to use the concentrations given from earlier. Each of these guys are 1 molar. Sorry, so this is 1 molar, this is 1 molar. So if you backtrack and you look at this, there's 1 iron ion, and that 1 iron ion will have 1 molar concentration. 1 times 1 is going to be 1, so 1 molar for iron 3 plus. And then because this one gets multiplied by the 1 molar here, this ends up being 3 molar ClO4 minus. And that's how you get that. So remember, with ions, it's a little bit more involved because the actual molar concentration gets multiplied by the number and subscripts indicating how many of those particular ion atoms are there. So that details solving molarity-based questions when you're tasked with solving for molarity, and that completes the lesson.